All right, so picking up, we did 10, A and B, and then C we had not gotten to. So just as a refresher, what we're trying to do is we're trying to use the linear approximation 1 plus x to the k, and this number out here has to be 1, and then we can write it as 1 plus kx. So we have to factor out something and then rewrite it. So the first thing I would do here is I would go ahead and rewrite this as 1 plus 2, nope, not 2, 1 over 2 plus x to the 2/3.
Wait, how'd you get plus? That says 1 minus.
I don't know. I think because I was thinking of the 1 plus x to the k.
Yeah.
I don't know. Anyways. All right, now on this one is a little bit different in how we end up giving our final answer compared to the previous ones. So obviously this isn't just an x on top here,
Right.
but that's okay because this is a 1 here.
Right.
So that we're good to go.
So as long as the first thing is a 1 and there's an x in the second thing, everything's fine.
Everything is fine.
Okay, so we just leave that.
All is good in the world at that point.
We just let it be what it wants to be. Okay.
I was going to say it's 2025, but it's not the case anymore.
Error.
Remember the thing was passed that there's only 2 genders now. You can't be what you want to be. You've got to be what you are. You know what I'm talking about? You look confused. Just disregard.
I'm lagging.
Wasn't trying to break you. Alright, so this ends up being 1 minus, and then we multiply the 2/3 in there, so 2 over 3 times 2 plus x, which I'm going to rewrite as 1 minus 2 over 3, nope, 2 over 6 plus 3x. There we go. And that's how that one gets left. Which just always seems weird because it doesn't technically look like that form, but the x is there, so it's fine and dandy.
If you say it's okay, I trust you.
Seems odd to me, but the book says that's the right answer. So we're going to roll with it. I guess it's just because technically the number in front can be anything, so it doesn't really matter, but who knows. All right, next stuff. Approximate the root by using a linearization centered at the appropriate nearby number.
What? I looked away and I didn't catch any of that.
Virginia, you're going to have to take this one. Approximate the root by using a linearization centered at the appropriate nearby number.
Okay, now I was paying attention and I still didn't catch that.
Cube root of 26. All right. What is the closest known cube to 26?
So do you want me to say 27 or 3?
27.
Okay.
So this is closest to 27. So x equals 27 is what we're going to say. So now f of x is the cube root of x, or x to the 1/3. What would the derivative of that be? Beautiful. Now, huh?
I remember that one.
That's good. No quiz so far. F prime of 27 equals 1/3 times 27 to the negative 2/3, which is 1 over 3 times 27 to the 2/3. So the cube root of 27 is 3, squared is 9, times 3 is 27, so this ends up just being 1 over 27. Are we tracking? Or are you still lagging?
Hold on, I am lagging. I'm going to have to write out all of that so that when I look back, I can follow it.
That's fine. There's one other thing I'm going to write up there with that I should have written to begin with, just for reference, but it's fine that I didn't. We'll just go back. All right, so this is A, and this is f of A. So if I plugged in 27 for x in this initial here, I get 3. So it's just a different way to kind of write the information we already knew, but just to have it for reference. All right, so now the linearization. L of 26 equals f of A, which is 3, plus f prime of A, 1 over 27, times the actual number 26 minus 27, x minus A. So this just ends up being 3 minus 1 over 27, which is 2.96. So by using that information, we can figure out what that is approximately. Now, let's see. I'm just curious if I actually do this. The cube root of 26 is 2.96. Plus a little bit, but 2.962 would be the actual, which it's not asking us to figure out what the error is. They just want us to approximate it, so. Makes sense.
I think so.
That's good. Let's do another one.
So, like, what do we do if it was, like, a lot farther away from something?
They're not going to give you one that's farther away.
Oh.
They're all going to be close.
Oh, yeah.
Like one of them's 998. One of them is 101. Like the square root of 101. They're all going to be relatively close. I mean, this isn't going to be accurate farther away. It's just like you've got to be in that general range. So.
Like, what did they give you? The cube root of. I couldn't remember if 9 squared was 721 or 729. I just had to check. What did they give you, like, the cube root of 720? Would we be able to go with the 729 and be close?
I think it'd probably be. I mean, it will be. It's an approximation. So the farther away that the number is that we're using, obviously, the less accurate that it's going to be.
Right.
All right. So what would x be for this one?
81.
So square root of 81 is Are you glitching?
Well, I mean, I know it's 9. I was.
Okay.
I thought you were exchanging. I know
I was hoping so. All right, so x is 81. Square root of that, which would be the f of x, is 9. So f of x is equal to x to the 1/2. So I'm just rewriting that to begin with because there's no reason to write it square root of x and then x equals or x to the 1/2. There's just don't need to do that. So I just realized it's not still raining.
Yeah, it stopped raining like during third period, probably before that. But when I went over to choir, it wasn't raining.
Oh, I was working on my videos for my class. I had AirPods in, so I wasn't listening. That's why I was like, oh, it's not raining now. It's supposed to start raining again later, though.
Hopefully not around like 3 to 3:30.
No, it's supposed to like 8:30.
Oh, okay.
Something like that. I don't know why I said 8:30. I don't know. The weather thing says sometime between 8 and 9. At least that's what it said this morning. And it's supposed to rain till like 3 a.m.
I just didn't want to get rained on while I'm on my car.
Yeah. Next week, we're supposed to have a thunderstorm. In February. That's crazy. I guess this groundhog is not going to see his shadow.
Unless there's like lightning. And then like flash, light, shadow.
I went and visited the groundhog. I've seen him in person.
How was that?
It's a whole town full of groundhogs.
Oh.
It's pretty cool. He lives there with his wife, Phyllis. And his kids, I think, are like Sonny and Cher.
Sonny and who?
Cher.
Oh, I thought you said chair. Like the thing I'm sitting
Yeah.
on right now.
Yeah, no, we went to the site where he, like, sees his shadow or not. And we were, like, looking all over for him. And we're like, this might be a really dumb question, but, where's the groundhog? They were like, oh, he lives in town. He just comes here for Groundhog Day. I was like, oh, what? They were like, yeah, he lives at the library. And then she said, I had told Kenny that, like, he lived there with his wife. Like, I was kind of joking, but kind of being serious. I was like, yeah, I was like, his wife, he lives with his wife, Phyllis. He was like, groundhogs don't have wives. Like, that's just, it doesn't work like that. So when he asked the lady, and she goes, yeah, he lives there with his wife, Phyllis, and their 2 kids. I looked at him and I said, I told you he had a wife, and I told you her name was Phyllis. It was funny. I have a groundhog shirt. I'm going to wear it on Sunday for Groundhog Day. I was hoping Groundhog Day was going to be on a school day, but it's not. It's fine.
So, how does...
Random facts.
What does Groundhog Day do again?
See a little groundhog, furry and brown. He's coming up to look around. If he sees his shadow, down he'll go in 6 more weeks of winter. Oh, no.
I feel like in stats last year, there was something about a groundhog.
Probably.
Like, how accurate is this groundhog?
Not very.
Okay.
There's no rhyme or reason. They also do it at like 7 a.m. So, like, where's the sun? And they decide if he sees his shadow or not. It's a scam. But this whole town is obsessed with this groundhog.
They need,
Like, there is a groundhog everything. Like,
They need a
outside of the
groundhog
fire
everywhere.
station, there is a groundhog dressed like a fireman. Outside of the police station, there's a groundhog dressed like a policeman with a dog, like a canine dog. Then outside of the
There's
post
really-
office, there's a
that's-
postman groundhog. Outside of the donut shop, there's a baker groundhog. They are everywhere.
What if instead of having like a bunch of groundhogs dressed up as people, they have people dressed up as groundhogs?
Nah.
Well, I'm sure they do though.
Oh, I'm sure they do. You have to get to this place, to the Gobbler's Knob, at like 3 a.m. if you want to have a chance of seeing him. Like on Groundhog Day. It's crazy.
So, note to self, if you want to see that groundhog, don't go on Groundhog Day.
Correct.
And where is this groundhog?
In Punxsutawney, Pennsylvania. He's Puxatawney Phil and Puxatawney Phyllis. It was a cool experience to go once.
So is that like
You wouldn't go again.
last name, first name?
Yeah. Well, no, his name is Phil. He's from Punxsutawney, so he's Punxsutawney Phil. Other places have other... There's another groundhog somewhere else, but I can't remember what his name is.
Must not be important.
Well, it's not as famous as the this one. I don't know. Anyways.
How many have they had?
So according to their story that's posted about him, beside him, he has an infinite amount of lives.
So how did they choose?
Don't know.
Which one is the Phil reincarnated?
Don't know. He just is.
Does he actually have children?
Yeah.
Okay.
They literally, I mean, I
And
saw
is
them
the
all.
wife always Phyllis?
They don't die, so yeah.
Okay. So.
Virginia's gonna have a good time with this. She's gonna be like, y'all really just sit there and talk about a groundhog for 10 minutes?
Well, sniff, sniff. We talked about that.
Okay, let's rein it back in. What's the derivative of this?
Speaking of rain, there isn't any outside.
Yes.
Okay, f times x is 1/2 x to the negative 1/2.
All right, now we evaluate at 81. So 1 over 2 root 81, basically just converted when I plugged in the number. Get 1 over 18. So the square root of 80 is approximately equal to the linearization of 80, which is 9, plus 1 over 18 times 80 minus 81.
So your little approximating thing that's a squiggly equal sign is supposed to be a little more separate, right? It looked like a really squiggly X.
Yes.
And your L, it looks like a less than. Ooh, fancy.
I think I was meant to have an L in my name. I think L's my favorite cursive letter.
Well, you took the L on that.
Yeah. Kenny has an L in his name.
You jealous?
Look how pretty that one is! I did so good!
It looks so wobbly.
Okay.
Dang it. I can't write 80. I wrote 81. I wrote 88. Here we go. 80. Okay. Everything's fine.
So this is 8.94 repeating. If I actually do the square root of 80, nope, not that button.
What button would you press?
The square.
Oh.
8.9442. Nailed it.
Close enough.
Anyways, good enough.
I mean, that's probably about as far as you can go anyway.
Typically, yeah.
Are most of these just
Technically,
that one was a repeating one.
yeah, a lot of times they're repeating, and we usually just round.
I didn't sleep the best last night, so that's my excuse for being a little off today.
Not last night, but the night before. I wonder if it was a full moon. I didn't sleep great. I was up like 3 different times. It's fine. All right, 16. Y equals.
I think my calendar at home has like moon phases. At least like
And the nuns.
Right, the holes, the halves, you know, like, it's like a whole, you see the whole thing.
Or you don't see
half
the whole thing.
Right, you see the whole not thing.
Is it an open circle or a closed circle?
Open circle means there's a hole. Closed circle means it's there.
When I taught Algebra 1, I didn't even teach them that the circles were an option for graphing. Like, I didn't even teach them that this was an option. I literally taught them that the only thing that they could do was this or this.
Oh.
Because they always get confused, and it's easier just to teach the one from the beginning, so I just taught it that way. They liked it better.
So they didn't understand circle?
No, I just didn't want them to get stuck on the circles, because then when I force in Algebra 2, parentheses and brackets, people get confused.
Ah, okay. I understand. X equals -2. And dx equals 0.1.
All right, so the first thing that we are going to do, there's two parts. We are going to find dy dx implicitly. Okay?
Okay.
Do you know what that means?
The implicit thing makes me think of the y stuff.
Yes. So obviously this only has one y in it, but we're going to kind of treat it as if it was like the other way. Never mind. Just disregard what I'm saying. Evaluate dy for the given value of x and dx. So dx is a given value. So we're going to be moving the dx from the dy dx over to the other side to solve. All right. Get this right or you're going to earn a quiz. What's the derivative of this?
So dy is just y prime, right?
But write it as dy because we're solving for dy. Look, I'll just do this because you look confused, and then I'll erase it in a minute. I just need ignore that. I just need the derivative of 2x over 1 plus x squared.
Oh, okay. So that's 2 times 1 plus x squared minus 2x times 2x all over 1 plus x squared.
Good. Times dx.
Oh, okay.
That's why I was not writing this over here.
Yeah, I was going to say, does dy equal dx? But I forgot to take the derivative of the rest of it.
Yeah. So then just to simplify that, make it look a little nicer, dy equals 2 plus 2x squared minus 4x squared over, I'm going to leave that 1 plus x squared squared. Now, 2x squared minus 4x squared is negative 2x squared, so I'm going to actually do this. Because I don't want to rewrite it all. Tracking.
Mm-hmm.
All right.
If I had told you about the dx before you got to that, would I have got to negative b point?
No.
Okay. I didn't think so. That's why I say so.
Because I was in the process of still fixing it.
Okay.
All right, so now that was part A. Part B, we're plugging in -2 and 0.1. So dy equals 2 minus 2 times -2 squared over 1 plus negative 2 squared times 0.1. So what's that? 4 times negative 2 is negative 8, plus 2 is negative 6, over negative 2 squared is 4, plus 1 is 5, squared is 25, so negative 6 over 25 times 0.1. Now we need our handy dandy calculators. Which is a lovely negative 0.024. Nice and easy, right? I enjoy this stuff. These ones are like satisfying to me. Ooh, now I have a good one.
Oh no, not the friction.
Just work.
Virginia's really missing out.
2y equals x squared minus xy. X equals 2, dx equals negative 0.05. So we could either do this implicitly and then have to play around with it after, or I could get the y's by themselves. Okay, so let's do that. So I'm going to move this one over. So 2y plus xy equals x squared. What would you do now? Oh, good. Now we divide. And now we can take the derivative. Josh, this one's all you. Mainly because Virginia's not here.
So used to writing dy dx, so I wrote my dy really tiny. X times 2 plus x minus x squared all over 2 plus x squared times
The little dude. The little drummer dude.
I mean it's negative 0.05, so it's very small.
Alright, so this is 4x plus 2x squared minus x squared over 2 plus x squared dx. Then I'm going to take and rewrite this 2x squared minus x squared just as x squared to make life simple. That's part A. Now I shall plug in the numbers. We have 2 and negative 0.05. 4 times 2 plus 2 squared over 2 plus 2 times, squared times negative 0.05.
I'm also malfunctioning.
Negative 0.05. I was glitching.
I glitch all the time, so I get it.
All right, so we've got 8 plus 4, so that's 12 over 4 squared, 16. So we've got 12 over 16 or
I forgot the
3 over 4
little
times
huge.
negative 0.05. Cookie point for Virginia. 3 divided by 4 times negative 0.05. We get a lovely negative 0.0375.
That will do. 12 over 16 times what is it? 4 over 3, and then whatever Stacy wrote. I circle you. And you're an even littler dude. Well,
The little dude. All right.
closer to 0.
True. All right. Find the differential. This literally just means take the derivative and write dx. So, 24. D of e to the 5x plus x to the 5th. So you just need to take the derivative of what's in that parentheses and then write dx after it all.
So that's like,
So what's the
Okay.
derivative of e to the 5x?
hold on. I gotta write this as dy, alright?
It's not dy.
But y is whatever's in the parentheses, right?
There's no y.
But if there was a y, would
This
y
this
be equal
isn't
to-
that though. This
Aw,
is
dang.
different. This is a differential.
Oh man, I can't brain it that way.
I mean, you can, but I wouldn't write it that way because that's
I
not
wasn't
right.
going to write it that way. I was just going to write a little note so that I understand.
This isn't that though.
Stink.
This is just the derivative of this stuff.
Okay. 5x
What?
No, just 5 e to the 5x.
You're about to get a quiz.
Thanks for saying what. I forgot that we don't take the x. Just take whatever's with the x.
I was like, chain rule.
Just, yeah, I forgot that we just steal the x's friend.
Yes. His friend goes bye-bye.
Oh, well, friend gets duplicated and thrown out. And that's,
The friend has a twin.
Mhm.
The evil twin.
The bigger twin. Well, like actual size, and then that's 5x to the 4th.
Then we put parentheses around this and we write dx.
Okay.
Kind of like the plus c with the antiderivatives. If we don't have dx, it's wrong.
I feel like Virginia's gonna think I'm stupid. She probably already thinks that, but also she thinks I'm really smart.
D of 8x plus x to the 8th.
8 to the x plus x to the 8. Now hold on,
Holding.
let me flag.
I'm holding on.
Let me just error this. Alright.
I'm still holding. See if you remember this exponential derivative.
That's not it. Eight to the x ln of 8 just doesn't look right.
What'd you say?
8 to the x ln of 8. Well, times ln of 8.
8 to the x ln of 8. Yep.
Okay. It looked right, but not. Then that's 8x to the 7th.
Beautiful.
Yeah, you know, Biz.
DX.
Welcome, Virginia.
The X.
Yeah.
Can't forget the X. Alright, the last thing in this section are a few little like word problem-y thingies, but I think I'm going to save those for Monday because one, there's not enough time to do them, and two, kind of need to be able to do the other stuff to do these.
I'll make sure we're here for those.
So, problems are so far.
They give me the most problems.
I have a lot of problems, that's for sure.
Yeah, and you dump them all on your students.
1, 5, 9,
Math teacher.
11, 13,
5.5, right?
15, 17, yes.
Thank you.
21, 23, and 25. And then I'll add 3 more on Monday.
How many?
3.
Okay. Yeah, let's space right through more on the top of the page. I wrote them.
They're not hard. It's just one page of examples that are left.
Yeah, I just wrote the problems really big. So.
Yeah, it's just a couple more of the word problems that go with what we're going to do on Monday. So if you knock these out this weekend, it won't be too bad. And then we've got a whole section of word problems after this one.
It's giving stats. In terms of quantity of word problems.
Fair point.